Hi everyone. This is the third lecture for the first day of calculus differentiations. Um, we have unique cases here. Of course, they are unusual as compared to the last two videos. The first one here says, if a equal to pi r squared, find the ADR. Of course, most of you can remember pi r squared as area of a circle. All right, we are given a equal to pi r squared. We want to find the ADR. So the first thing to inform here is not all the time we say dy dx. It depends the function that we are given. Here is a function a in terms of r. Yes, so this function is a. We say dA in terms of r, radius, so dr. So beware, we have here pi, we have r. But what is our variable here? Our variable is r. So it tells us that pi is a constant. So we are considering the power of r and the coefficient of r. What is the power of r? Is 2. What is the coefficient of r? Is pi. So the power multiplies the coefficients. So 2 times pi is 2 pi. We write the variable r. So what next? The power minus 1. So 2 minus 1 is 1. So which we can just ignore. Then we have 2 pi r. So what is the conclusion here? If the area of a circle is given, then you differentiate it once. You will get what? The circumference of that circle. Okay. Here we are given s equal to ut plus half at squared. This is one of the equations of what I say, mechanics physics. Yes, one of the equations we talk about in motion mechanics. All right. So we are given s, equation of motion. Thank you, equation of motion. We are given s to be ut plus half at squared. Then want to differentiate, want to find the derivative. That is what? ds dt. So the function is s ds with respect to t. So we are differentiating with respect to t. So it tells you that on the other side of the function, on the other side of the equation, t is the variable. So whatsoever that is not t is a constant. U here now, it's a constant. A, it's a constant when trying to differentiate. Generally, u is not a constant because when you talk about u, we mean what? Initial value, v, the final. Is that also? So these are speeds, initial and final. And this is the acceleration, this is time. But differentiating now with respect to t, we treat u as a constant, a as a constant. Okay. The first term here is ut, where the variable is t. The power is 1, the coefficient is u. So 1 times u is u. We write the variable. Do not forget that we must say what? Minus 1. So if here is already 1, they will say minus 1, we have 0. The next term, we are going for t. T is the variable. What is the power of t? Is 2. What is the coefficient? Is half a. So it means 2 times half a. 2 times half a. What do we get? We just get a. Then we write our variable. Let us don't forget that the power minus 1. So 2 minus 1 is 1. So this tells us that any value raised to the power 0 is 1. A power of 0, sorry, a power of 1, we ignore it. So we say 80. So this is u plus 80. So in mechanics, whenever you differentiate this, what do we get? We have u plus 80. U plus 80. So it tells you that ds dt is v in mechanics. Okay. So the last one is here. V is equal to U plus AT. Then we want to differentiate V with respect to T. So say dV dt. T is the variable. So U and A, we treat them as constants. So if we want to differentiate U, this term does not contain this T. So it's a constant. Differentiating a constant is 0. We differentiate this with respect to T. What is the power of T? 1. What is the coefficient? Is 1. Is A. So 1 times A is A. But the power must always lose 1. So this 1 minus 1, we have 0. So 0, we forget about it. This is A. A value raised to power 0 is 1. So finally, we have A. So what can we say now? When you differentiate S here, distance displacement, what do we get? We get U plus AT, meaning we get what? This V. When you differentiate V, what do we get? We get the acceleration. So thank you for watching. Don't forget to like and share. Bye-bye.